Okay, so we've calculated the voltage at a particular location in space due to some charges. But you probably had this idea that if I brought in one charge, that it would take some work to assemble, to bring that charge into this location. And then if I wanted to bring another charge in, then I'm going to have to deal with those two charges. So let's start basic here, and I'll think about a positive charge. And if I wanted to bring a charge nearby it, let's just give this some names here. So this, let's say, is some Q1. And if I wanted to bring another charge to this location, I don't know, let's say that this charge has some Q2, and I'm just going to call it as another positive charge here. If I wanted to bring some Q2 all the way to this location here, we might just ask this question, okay, how much work would I need to put into the system to bring these two charges? They don't want to be near each other. I've got to try to push them together. How do I do that? So I know that the voltage, because of this charge 1, is just equal to kQ1 over the distance from this point here to any point that I'm interested in. And if I want to talk about the work that I want to do to bring in this Q2, I should think about the voltage from this number 1 times Q2, and that'll be the work that I need to do. Okay, so what if I wanted to try and figure out then the work that I need to do to bring in a third charge? So I'm bringing that in from somewhere over here, and I'm bringing it in over here. And let's say that, for example, that this now, we have to get a little bit more specific with our details here, is that if I have some distance d here, and let's say that this is some distance d here from this charge to this charge, okay, then it looks like we're going to need to also consider the fact that this is the square root of 2 times d, because we have now a kind of 45-degree triangle. So we calculated the work that it takes to bring in this second charge, but now what about the work that it takes to bring in this third charge? So if we bring in this Q3, I'm actually going to need to compute that the work to bring in Q3 is going to be the voltage at this point times the Q3. And so what we'll need to do then, if we need to think about how much work it takes to assemble charges, we'll need to actually consider bringing in each charge one at a time and then computing the work. So for example, I could compute the work to bring in number 2 as being K Q1 over D times Q2. Okay, so that's going to be work 2. But now the work to bring in charge 3 is going to be the potential here at this point, which is going to be K Q1 over this distance here, which is going to be the square root of 2 times D, plus K Q2 over this distance D. So, and then all of this is going to be multiplied by Q3. So you can see here that finally our total amount of work that we need to do to assemble all these charges, you can think of it as that if there's no other charges in space at the very beginning, simply just bringing that first charge into a location doesn't really cost any energy. But it's when we start bringing in a second or a third charge that we're actually going to need to make this computation of each time we bring in a new charge, we need to consider bringing in this new charge, and he says, hi guys, right? And they need to actually talk, or how do you say, we need to have some acknowledgement of the fact that there are more charges now in the picture. So if I do this, I can say it's W2 plus W3. And so for example here, if I just plug in these what I calculated here, we can have K Q1, Q2 over D plus, and then this whole thing over here, which is going to be K Q1 over the square root of 2 times D plus K Q2 over D, and this is going to be Q3, and this is going to be Q3. So again, I can plug in some specific numbers here if I'd like, but for right now I just wanted to make sure that this is a conceptually clear idea here, is that if we wanted to, for example, bring in a Q4, that might be a problem that you do for a homework assignment or something that might be on an exam, is that you can then compute the work that it takes to bring this thing in, because now you have 3 charges in here, and you can calculate the voltage at this location and multiply by this Q4 in order to compute the work that it would take to bring this Q4 into this fourth corner of a square here. So, so I'll leave that for you, and we would be then computing this W4, and we would add that onto our list. So you can see that as you start to add, include a lot of charges, you can start to see that this becomes a very, very long summation. But nonetheless, it allows us to compute the amount of work that we would have to do in order to assemble a group of charges.